This meeting is being recorded.
Hi everyone, welcome to this year's Chat Physics Live 2022. I'm Thandi Banda. On Twitter it'd be Thandi Banda, and I thought for this year I could talk about something that I've tried with some of my low attaining and high attaining classes, and as regards extended reading, extended writing and multi-step in physics. The main purpose of this really is to give teachers, particularly new teachers, just some reflection points in terms of how to develop student resilience and how to make sure that we understand what examiners are looking for in physics exam questions, and also develop those mathematical skills which they may not get from maths itself, because there'll be very few multi-step calculations, maybe one in a paper, but for physics these are becoming much more common. And the good thing about multi-step is that it's spreading to other subjects. So biology had their first multi-step a couple of years ago. And I think it's important that we embed this in our teaching to make sure students have the resilience and the skills to tackle these problems. So just to give a bit of context, at the school that I'm at currently, our combined science students really struggle with extended writing. Majority of the students left extended writing questions blank. Physics in particular, apart from practicals, physics in particular was the one that was weakest. So I thought, well, we need to do something about this as faculty lead. And for physics, I think the challenge with extended writing, particularly that most physics is taught by non-specialists, is understanding how to link concepts, and that's where really powerful modeling comes in. And for any new teachers and non-specialists, it's that development into, if a student has written a 6-mark answer for an extended writing piece, is it just a list of bullet points, bullet points are fine, but are they linked? Are they in context? Have they actually answered the question? So I think the classic example is comparing alpha, beta, and gamma radiation, where they can write all the facts, but have they linked to the properties and the structure of alpha particles, anything like that, to make sure that they've actually answered the question. So what I decided to do for my action research, we do action research as part of our professional development, is I thought we would embed extended writing into the curriculum planning. And so every half term there was a piece of extended writing that all the teachers have to do. But in physics in particular, really well modeled. We use booklets, so every 4th lesson has an extended writing piece, so that the teacher can really model extended writing, and teachers needed like just a reminder to make sure they're modeling extended writing. But also we did some CPD to make sure all our non-specialists are well versed in the linking aspect of extended writing, whether it's biology, chemistry, or physics. Multi-step is something that is only in the higher papers and the triple papers. So what we are trialing at the moment is really teaching multi-step as a standalone sort of delivery model, and making sure that the whole class can do multi-step. And like I said, these can be spread to physics, to chemistry and biology as well. So 2 methods then, because of the difference in ability groupings, what we wanted to do is make sure that the participation ratio is really high. So for our low attaining groups, I'm using mini whiteboards to draft extended writing. And the good thing about using mini whiteboards, which I think some teachers would be very reluctant to use for extended writing, is that students can redraft on those mini whiteboards. And one of our colleagues from English showed me the idea, and I thought for physics and for chemistry, this would work really, really well. The other great thing about mini whiteboards is that it gets rid of that opting to do the work. So it's a not opt out expectation, and it's guided at the beginning, and then you fade it out, and making sure you're giving feedback throughout. So what I have as an example is an overlap question, which looks at evolution of the atmosphere, and you can stretch this to then greenhouse effect. So this is found more in chemistry, but these sorts of questions are appearing more and more in physics. And what you can see here is these examples are from two of our lowest ability students in terms of literacy and in terms of reading age. And what the mini whiteboards have done is that they've, due to the guidance and the modeling and the high success rate of, because they can redraft before they transfer this to their paper, the students are trying extended writing a lot more, so we're getting quite a lot of success. I've got a lot of other examples, but our year 10s are doing exams, so they've got their booklets with them, so I couldn't take more physics examples, but this one I had an example of, so I thought I'd share this one as well. I think just as a word of caution, please don't give students extended writing to just go and do whatever they want, whatever they think, because it can create quite a really bad feeling towards it, because students are not confident. So before mini whiteboards or extended writing is done, it's making sure that you've had guidance, whether it's structure strips or just modeled guidance, especially with your lower ability groups as well. For the high attaining groups, I have white desks in most of the classrooms in the department, and they have worked amazing for think, pair, share, but in terms of doing mathematical concepts and extended writing. So what we do is there's a question on the board and they race against each table after there's a lot of modeling. So I'm confident that they can all try it. And this is full participation. But because it's think, pair, share to start with, these students can then really share each other's ideas and really try, and they can think about what they've missed out. They can then have some time after the time is up to look at the next board. And I'm circulating at this point to make sure that every student has tried the question before I then model the answer. The key thing that we were noticing with the exam papers is that students were not decoding the guidance from the exam board. They were not decoding the command words. They were missing out definitions or explanations and writing descriptive methods or descriptive answers. And what we thought we could do is with this, they can really look at their answer and really evaluate it. But because of the competitive nature of this, everybody wanted to try. And again, some students may not like competition, but for us, it's worked really, really well because we've made sure the students are comfortable in doing this. So again, we didn't just roll it out and say, right, we're using tables for this. It's all challenge themed. It's all competitive. We started very slowly and then it built up, and checked using diagnostics that students were confident in the topic before they did this as well. So these are a couple of examples from the desks. What we've done here as well is that during the exam period, Dr. De Bruin on YouTube did a lot of walkthroughs. So we set those as challenges, and they were compulsory for our students, for especially the core group of students, and their minimum was to make sure they've done I don't know, 3 6-mark challenges from the YouTube videos, and they watch the videos and they answer the questions. Then when they come to the classroom, we ask them the questions again. So thank you so much to Dr. De Bruin for those videos, because our year 11s have really benefited from them. And what you can see here is they're really correcting their work as you are talking them through it on the desks, and they're talking to each other as well, and they're looking at each other's work as well. For multi-step, I think our method of using FIFA model answering of questions has come from Gettin, who's part of one of the co-authors of Cracking Misconceptions. So thank you so much. And what you can see from here is that ideally, multi-step, to me, I sell it as the funnest part of the course, because it is just decoding a question and then you go. If you can identify the equations that you need, and sometimes it's 1, sometimes it's 2, but it's the idea that it's multi-step. You need more than one step. The examples that I've shown you here are 2 of our least confident students, and they were happy for me to show you this. that have really worked hard on multi-step confidence building, and they to the point where we've made a booklet and they tried all the questions in the booklet. With this, the way I pitched multi-step is, let's aim for 3 marks. And everybody just aims for 3 marks. Once they get the 3 marks, then I ramp it up, and then introduce the competitive nature to it. And what we found was every child in the classroom is trying multi-step. We've just rolled this out to year 10, because I thought if we start early with year 10, by the time we get to year 11, then what we could possibly do is actually write our own multi-step. Because for me, what I think multi-step teaches you is the connectivity of physics. And if you understand a concept really, really well, if you understand energy stored transfers, if you understand latent heat and specific heat capacity really, really well, you can see the link between the equations. They make sense. And that's why I love this. It's really high challenge, but it is doable. And it's quite nice being able to predict what's coming up in the next exam, because it could be any combination of equations. So it's really, really good to try this one with your students. But again, make sure they're confident before you roll this out. So just as a summary of what we found, so over time, we are finding our year 11s and our GCSE classes, their routines are really developing. 100% of our separate science classes are meeting the benchmark, that 3-mark benchmark for multi-step. They've all met it in the last set of mocks, which is really, really good, because the November mock before that was 0 for the multi-step. What it's done, it's increased motivation after their physics exam. The key thing they wanted to talk to me about was multi-step, and it made my day, and it made the other physicist teachers' day, and I think this is a real win. So I think rolling this out to possibly year 10 and year 9 is a really good idea, and then trying to formulate multi-step together with the class is a really good idea, but it's making sure it's inclusive and you don't pitch this as something that can only be done by a few. So don't call this grade 9 questions. It's making sure every student feels that they can try it and they can do it as well. So I think to finish this off, if you want to really see booklets that have multi-step embedded, have a look at Peter Edmonds' blog, and he's got loads of booklets where multi-step is embedded. And Gettin's FIFA idea for multi-step is on his blog, so I've linked it there. And then Adam Boxer is really brilliant at getting you to think about your practice. So his blog on his blog page, Chemical Orthodoxy, is really good, particularly the blog that I've really loved. There's a lot of brilliant blogs on there, but the Power of Bi talks about clarity of explanation, but also how to do equations and making sure everything aligns so that students are following through the thinking, as opposed to writing an equation in another part of the page, then doing the working on another part. And then lastly, I would say, if you're teaching more than one science, please use these ideas for the other sciences. They do work. The sciences are getting much more mathematical, in my opinion, in terms of application. And the extended writing is getting a lot more application based. So the more we can get students to think hard, the better. The more we can develop students' knowledge, the better. So hopefully you've gained something. There'll be a chat on Thursday about this. So please just watch the video. I think I've put some discussion questions into what do you think? Do you think starting at year 9 and year 10 is a good idea? So ideally, these questions could be discussed on Chat Physics on Thursday when it's my slots discussion time, and I'll be around to answer any questions that people have. Hopefully this will evolve as well. It's in its infancy, but I can see this evolving and becoming really embedded over the next few years and becoming part and parcel. I think if we can then take this to A level as well, for paper 3 practice, this will work really, really well as well, because one of the key things that sixth form students sometimes forget is to show their working and to really show through the thinking and their steps. And I think this will really help as well. So thank you so much for listening, and hopefully I will be able to discuss this further with you on Thursday's chat. Thank you. Bye.